Welcome to the Explainer. Hey, if you're a focused learner looking to retrofit an elevator into your property, you've definitely come to the right place. Today, we're going to completely decode the technical jargon of home lifts. We're drawing straight from highly detailed, expert source material written by Pneumatic, a technician head at Cibes Lift who's got years of on-the-ground installation experience. By the time we wrap this up, you're going to know exactly how to find the absolute perfect fit for your specific space.
Okay, let's dive into this. Here's our roadmap. We'll cover the home lift dilemma, 5 core lift technologies, comparing structural requirements, the screw-driven solution, a Bengaluru villa case, and finally choosing your best fit.
Section 1. The home lift dilemma.
Now, this is the very first major hurdle every single homeowner faces when they think about retrofitting an elevator into an existing property. It's the big question staring you right in the face: which lift technology is actually right for our home? Look, if you're feeling anxious about making major structural changes to a house you already live in, you are totally not alone. The thing is, not every lift works the same way. The core movement mechanism, the actual tech moving the cabin up and down, literally dictates everything. It decides if you're going to need to dig deep pits, build external machine rooms, or totally tear down your walls.
Moving on to Section 2. 5 core lift technologies.
So we really need to categorize these systems because each one moves differently. And because of that, it affects your house in entirely unique ways. First up, we've got hydraulic lifts. These move using a fluid-powered piston system. Basically, an electric pump forces hydraulic fluid into a cylinder to push the car up, and then the fluid just returns to a reservoir to lower it. They're super reliable workhorses, giving you a really smooth, gentle ride and handling heavy loads like a champ. But here's the catch for your home. They generally require you to factor in a totally separate machine room and a pit at the bottom of the shaft.
Next, we have traction lifts. You already know these. They operate using ropes or belts connected to a motor and a counterweight. These are the familiar systems you ride every single day in high-rise commercial spaces and apartment buildings. But for private residential use, well, they usually demand some pretty heavy upfront planning and a whole lot of dedicated space. And that brilliantly brings us to our third technology, the machine roomless or MRL lift. MRLs are really closely related to traction systems, but they solve a major spatial problem. See, they place the motor directly inside the shaft itself, usually right at the very top. This completely removes the need for a dedicated external machine room, which saves you some serious structural space.
Our fourth type is the pneumatic or vacuum lift. Now, these are visually striking. They use a cylindrical, transparent shaft and move the cab by simply altering the air pressure above and below it. Less pressure above, the car goes up. Release the pressure, and it descends. It's kind of like magic. These are incredibly appealing for older or heritage properties because they require zero pit and zero machine room. Just keep in mind, they are definitely best suited for lighter loads and traveling up to about 5 floors.
Finally, we have screw-driven lifts. Here, a threaded steel screw is mounted vertically. The lift cabin connects via a drive nut, and as a motor turns that nut, the cabin just glides up or down. Because the nut never actually disengages, it's mechanically self-locking. This self-contained, continuous threaded engagement creates a highly controlled, safe ride. And honestly, the best part? It doesn't need a machine room, and it often requires little to no pit at all.
Section 3. Comparing structural requirements.
Okay, it's time to translate these abstract technologies into concrete spatial realities for your home's blueprint. When we compare the civil work required, you can see some really drastic differences. Notice how hydraulic and traction systems almost always demand pits and extra rooms? But then look at pneumatic and screw-driven systems. They require zero machine rooms and almost no pit space at all. This is literally the difference between a minor home improvement project and a massive construction headache.
Section 4. The screw-driven solution.
Given the pretty tight layouts of a lot of Indian residential spaces, let's zoom in on this highly practical technology. With a screw-driven lift, you get that mechanically self-locking safety feature right out of the gate. You completely eliminate the separate machine room. The pit requirement drops to a tiny 100 millimeters, or actually even 0 millimeters if you use a small ramp. This makes it absolutely brilliant for tight retrofits. Yes, you do trade the high-speed capability of a commercial traction lift, but in return, you get ultimate space-saving efficiency, top-tier safety, and it still easily supports loads of 350 to 400 kilograms.
Section 5. A Bengaluru villa case.
Let's move from theory to a real-world anchor here. Imagine trying to fit an entire elevator into an incredibly tight ground plus one layout, 950 by 1150 millimeters. That is barely a single square meter. Could you even imagine fitting a fully functional lift into a site dimension this small without completely destroying the existing structure of the home? No way, right? Sounds totally impossible.
But actually, here's what happened. So the crucial point is, by choosing a specific screw-driven model, the Cibes Lift, this family managed to fit a 930 by 1,132 millimeter lift perfectly into that tiny available cutout. They didn't have to push the project into major budget-draining civil changes at all. The technology seamlessly matched the literal footprint they had to work with.
Section 6. Choosing your best fit.
Let's consolidate everything we've just learned into some rapid-fire, actionable takeaways for you, the homeowner. This is probably the most common FAQ from the source material. Which lift technology is actually best for a duplex or a 2 to 3 floor house in India?
Well, the answer is pretty clear. Screw-driven and pneumatic lifts are generally your most practical and retrofit-friendly options. For low-rise, existing homes, these two technologies drastically minimize the painful civil work, the endless dust, the noise, and the massive spatial sacrifices that are usually associated with home retrofits. Let's reinforce this space-saving motif one last time. Does a screw-driven lift need a pit or a machine room? If you've been following along, you probably already know the answer to this critical structural question.
Absolutely no separate machine room is needed. You're looking at a minimal pit, often just 50 to 100 millimeters, or literally 0 millimeters if you utilize a ramp configuration. It just goes to show how non-invasive modern lift technology has actually become.
I want to leave you with this fantastic quote from our source author, technician head Pintu Mato. He writes, "What matters is matching the technology to the building, the usage, and the people who use it every day." See, there is no universal winner here. A traction lift is great for a skyscraper. A pneumatic or screw-driven lift is brilliant for tight residential retrofit. It's all about making the exact right engineering choice for your specific spatial constraints.
So, here's my final question for you to consider today. Take a real hard look at your own home layout based on the exact space you actually have available right now. Which of these lift technologies truly belongs in your blueprint? Go ahead and measure your space, keep these structural truths in mind, and let that guide your research. Thanks so much for joining me on this explainer, and hey, happy planning!